Hello everybody, today we will be going over a geometry problem at the IB Math Studies level. So here we have that money boxes are coin containers used by children and come in a variety of shapes. The money box shown is in the shape of a cylinder. It has a radius of 4.43 centimeters and a height of 12.2 centimeters. And they ask us to, part A, find the volume of the money box. Okay, so first things first, with any problem, especially geometry ones, I would say you want to write down what the problem gives you. Okay, so we got the radius, we got the height, and we know that it's a cylinder. Okay, so right now I am writing down the obvious information, right? The distance of the radius, the distance of the height, and for the cylinder, we're going to go to the formula booklet, find cylinder under topic 5, geometry and trigonometry, and find the formula that we need. So the volume of cylinders is pi r squared times h. Now, most of the time, it's not going to be as easy as in part A here, where you literally just plug it into the formula and get the answer, because we do have r, we do have h, and we know that pi, and it's actually in our calculators, is 3.141, blah, 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 blah. Okay, but the value that I want to share here, or the tip that I want to share here, is that you want to write down everything to see what you're missing in the formula. In this scenario, we are missing nothing, so we can just plug and chug. Okay, so we have pi times 4.43 squared times h. Okay, in this scenario, I'm going to plug it all into my calculator. You can leave it with pi if you want. In this scenario, I just multiply it times pi because it's how I like to do it. And the answer is 752.151 centimeters cubed. Okay? It is very important that you put the units because this is part of the mark scheme. It's also cubed because we're talking about volumes. If it's squared, it's in respect to areas, and if it's just like a single digit, it's in respect to distances. And now moving on to part B. Part B is telling us that there is a second money box in the shape of a sphere and has the same volume as a cylindrical money box. And they ask us to find the diameter of the second money box. So, again, using the same process, we know that the volume of the cylinder equals the volume of the sphere, and that we're dealing with a sphere. The formula for a volume of a sphere is volume equals 4/3 pi r cubed. Okay, so using these two pieces of information, we can simply plug and chug and find the answer. So we end up with 752.151 equals 4/3 pi r cubed. And we don't know what r is, right? The 752 I'm plugging in here is the volume, okay, that we found in part A. And we know that both volumes are the same of both objects. And so working this out a little bit, you want to leave r alone, right? And so we can pass the 3 multiplying, the 4 dividing, and the pi dividing as well. And the whole thing to the square root of 3 will equal r. Okay, what I did here is just do the inverse of all the different things. So when I multiply by 3, for example, I'm getting rid of that 3. When I divide by 4, I'm getting rid of that 4. When I divide by pi, I'm getting rid of that guy here. And when I do square root of 3 and get rid of that guy. Okay? So all of that is here put on this side. So we work that out. We end up with R ends up being 5.64, 16, 9. And remember that you need to put the centimeters. Okay, a classic mistake here, and you want to be careful with this, is that people put this in as their final answer. Okay, and this is unfortunately wrong. The math is right, and this is indeed the radius of the sphere, but you have to look closely at the problem, maybe underline it, etc. The problem is asking for the diameter of the second Muddy box, and the diameter is going to be like the whole distance. I'm going to explain it visually. For a circle, for example, this guy is the radius, okay? However, if you do the whole line, like the whole way across, that's diameter, okay? And now if you just kind of like imagine that this is a 3D, whatever, man, this is a sphere, gotta go all the way. And so diameter is the same as 2r, because visually speaking, it also matches, right? Like you're multiplying the radius twice, okay? It goes both ways once, therefore diameter is going to be 2r. So using that formula, we're going to multiply 2 times what we got earlier, and we end up that the diameter is 11.2833. Are we done here? Not quite. Do not forget the units ever, because they are part of the mark scheme, okay? So very important that you put the units, but this is the answer for part B. Just a quick recap, okay? Be very careful what the problem is actually asking you. Never lose sight of that, okay? Maybe a good way to remember is that in the workspace that you have at the very bottom, write D equals when you're starting the problem. So then when you're at the very end, you remember that you're looking for diameter and not radius. And the other tip, which I think is far more important, is that you always write what you're gonna need and what the problem is giving you as well. Okay, that is why I wrote these 3 bullet points here at the beginning, and something that seemed very overwhelming, like finding the volume of a cylinder, actually ended up being very easy. The formula gave it to me all. And the second part, how the heck do you find the volume of a sphere? Nobody really knows that by memory. So if you just write down the information you have, you realize, wow, this is actually a lot easier than what I think. But for writing down the information that you have, you need to use the formula booklet. So that's another message I'm giving you. Get very familiar with that guy, because trust me, it's going to save you. So that being said, we are done, and I hope it helped.